Welcome back. I've got an interesting experiment for you today, and it's one that involves the rather unusual behaviour of LEDs when you plug them into different power supplies. So I've got a normal lab power supply here, and you'll notice that on this side it's got black and red sockets, and on this side 2 yellow ones. And when I do experiments with my students, I have to explain to them to normally use the black and red sockets and to leave the 2 yellow ones for other experiments later on. But what we're going to do today is connect an LED to the black and red one and see what happens, and then connect an LED to these 2 yellow ones and see if there's any difference. I've got a green LED here, and instead of connecting it straight to the power supply, I've put it on some long wires. And so what I'm going to do is connect the end of these wires to the black and red terminals on the power supply, and then swing the whole thing around my head when it's switched on. But then I'm going to do the same experiment, but connect it to the 2 yellow connectors and swing it around my head, see what result we get, and see if we can explain it. So I've got the LED connected to the red and black terminals on the power supply, and what I'm going to do now is just spin it around in a circle. And if you look carefully, what we generally get is a fairly continuous circle of light, a green circle as we spin this round and around. So let's now connect it to the 2 yellow terminals and see if there's any difference. So on the previous experiment, you will have noticed that the LED was lit and you got a complete circle as it went round. There might have been a few tiny gaps, and that's actually the shutter on the camera. So now I'm connected to the 2 yellow terminals, and let's swing it round and see what we get this time. And it's very strange. When we connect to the 2 yellow terminals, we get a circle of green light, but there seem to be gaps all the way around. So what I'm going to do is turn the lights back on and see if we can explain what causes this difference. So, time for an explanation. But first, let's have a bit of a story. So, many years ago, a couple of guys called Malcolm and Angus Young, who were playing in a really heavy rock band, needed a good name for their band, and they were struggling to find one. They asked their sister, Margaret, if she had any idea what they should be called, and she'd just been using her sewing machine, and written on it were the letters AC/DC. Well, the rest was history. So, the answer to this problem, why does the LED seem to produce circles that are non-continuous when connected to the 2 yellow terminals, is all about AC electricity. So if you look at the normal lab power supply, the one I've got here has got 2 sets of terminals. We know it's got the red and black terminals, and it's got the 2 yellow ones. Well, the red and black ones go to a DC power supply, and the 2 yellow ones go to an AC part of the power supply. And it's the difference between these two that explain why, when the LED is connected to the black and red terminals, it stays on all the time, and when it's connected to the 2 yellow terminals, it goes on and off and flashes. You might remember that LEDs and diodes only let electricity through them in one direction. And if we connect them correctly to the black and the red terminals, the black being the negative and the red being the positive, electricity will flow through them in one direction and they stay on. When I swing it around in a circle, the LED doesn't switch on or off, it stays on, and you should get a continuous circle. You get slight gaps because of the frame rate on the camera. This, of course, is known as direct current. That's where the electricity flows from plus to minus and always goes in the same direction, and therefore keeps the LED on all the time. So let's now look at what the yellow terminals do. You'll notice they're not separately labelled, so one isn't positive and another one negative. They're just both yellow. I've connected them, or at least something that's similar to them, to a centre zero ammeter. And this one, when not connected to anything, has a needle that sits in the middle. But when it's connected to yellow terminals, the needle swings from left to right and back again, and you'll notice that it keeps changing direction. Not only that, but it goes positive and negative and then back to positive again. This is alternating current, electricity that goes in both directions. It oscillates between going in one direction and then going back the other one, plus and then minus and plus. And if it's alternating in direction, with a current that's constantly changing its direction, this is AC, or alternating current. Right, we've got everything we need now to explain what happened when I swung the LED around in a circle connected to the yellow terminals. What was going through those was AC, alternating current. And because LEDs only conduct electricity in one direction, when the AC was positive, the LED lit, and when it was negative, the LED switched off. And because this power supply is giving AC at 50 Hertz or 50 cycles per second, it's going on, off quite rapidly, matching the power station generator that's making the AC. Then the LED will conduct electricity, not conduct, conduct, not conduct. So as I swing it around my head, it switches on, switches off, switches on, switches off, and we can be sure it's connected to AC because it's not staying on all of the time. There's one more experiment we can do, which is to connect the terminals of the power supply to an oscilloscope that will show us how the voltage and therefore the current is changing. So we'll connect to the black and the red terminals, the DC, and just turn up the voltage. And you'll notice that the trace on the oscilloscope just goes up and stays constant at a fixed voltage. But if we disconnect and plug them into the two yellow sockets, you'll notice that they are AC, that the voltage is going positive and negative all of the time. In other words, the current is constantly changing in direction because the voltage is constantly changing. And that picture is what we really think of whenever we think of AC electricity. So, next time you listen to AC/DC, you'll know what those letters stand for: alternating current and direct current. Hope you enjoyed that video, and I look forward to seeing you again next time.